This is a no-code neural network dashboard for training models in your browser. You can build custom architectures by selecting layers out here, such as linear, conv2D, or average full 2D. Now, if your layer has more parameters than just input dimension and output dimension, extra input boxes will show up down here carrying default parameters. You can either keep those default parameters or you can change them to whatever you would like. Here you have edit or delete a layer. So if you make a mistake selecting a layer in the add a layer section up here, you can change it down here by feeding it the layer index and feeding it the new layer type. If your layer type has more parameters than just new output dim and new input dim, new input box will show up down here, and it will once again carry default parameters, which you can change if you would so like. Down here, we can see the device that the dashboard is actually using. If we hit refresh device status, it will refresh the device it's using, along with the GPU context and the memory. Now, in this case, the GPU context is healthy. If there is a CUDA error, it will actually write it out here. In this case, this dashboard will have to be restarted. Out here in train, you can select the loss functions such as MSE loss or cross entropy loss, the optimizer such as SGD or Atom, the learning rate, the batch size, and the image resize in case you're making CNNs. And here you feed in the path to the CSV or zip. For today, for this demo, I'd like to use a CSV file created with some parameters about wine quality. We get a custom extraction path here. If it is not given, it'll use the C drive temp, and depending on the type of data and how heavy it is, it may overwhelm the C drive. So in this case, I'm going to give it my D drive. Here, I'm going to set the number of epochs. So 100 epochs for this small network are acceptable. Here, generate 3D descent animation comes unselected by default, but you can turn it on. For this demo, I will have this turned on. Just keep in mind, if you turn it on, it is actually CPU and RAM intensive. Here you can select target frames for video and the frame rate. Depending on how deep the network is, you're going to want to make these either smaller or bigger because each one of those frames must be calculated by that CPU. For this example here for today, this default is fine, so I'm going to leave it as it is. Here, we have the input channels. So it's either going to be grayscale or RGB in case you're making a convolutional neural network. Right now, we're not really using image data, so this doesn't really matter. We're going to build model, and the first layer is going to be a linear layer, which is 11 by 16. Then I hit add layer, and as you can see, something was loaded beforehand, so I can hit reset layers and clear that right up. We get linear first, then we get a ReLU. Then we get a linear 16 by 16. And next I'm going to put a conv2D layer here. This is not compatible with the other layers. It was supposed to be a ReLU, but as we shall see, the dashboard will be able to detect that. Now, the last layer is going to be 16 by 1, a linear layer. Now we go to train and hit train down here. You can see it stops training immediately. The reason is it's detected that conv2D layer is not compatible. So what we do is we come down here and give it the layer index. We want it to be a ReLU layer. So we can just hit edit layer. And you can see it's a ReLU layer now. Now we go back to train and we hit start training. We get live losses for every single one of those epochs. Now this network is going to train pretty quickly because it's shallow and the data set is not that big. And then it's going to go over and start plotting our 3D descent animation. So this is going to take a while to plot because it is CPU and RAM intensive. Every single one of those frames must be calculated. Now, as far as the custom extraction path goes, it will extract this data set to there, but it will delete it after training. So it will not leave files just lying around that are useless. Here we get our loss over epochs curve. Everything on this page here is downloadable. So if we download this, we can have it in our computer and view it here. So you can see it started off pretty high with the error, and it quickly came down here and stabled out to 0.5 as our losses here say, or around 0.6. Here we can get the 3D descent animation. And we can see the path that the neural network took towards optimization. So here it gets kind of trapped here, and it's kind of optimized already, so it didn't really need 100 epochs to train. But for more advanced networks, you can see the curve that it follows there. Here we have train model.pt, and we can download this as well. Now that carries both the architecture and the weights, so this should be ready for inference or anything on PyTorch immediately. I'm going to leave the Hugging Face, the GitHub, and the Docker URLs in the video description below. And this is all open source, and all the code is open as well. It's provided under an MIT license, and you can use it for whatever you would like to use it for.